not to understand quantum mechanics, for example. As I've often said, common sense, our deductions might suggest that you cannot be in two places at once. That is crazy. But of course, an electron not only can be, but it is. It doesn't make sense because we didn't evolve to know about it. We've learned about it. We force our idea of common sense to change. It's called learning. Some people would rather read an ancient book than learn. And this has been a very good evidence of that. For example, to say something is inconceivable just means you can't conceive it. But the great thing about the universe, and the reason that I do science, is that the universe has a much greater imagination than we do. In fact, there are more things in heaven and earth than are dreamt of in your philosophy. And that's what's wonderful about the universe. Things that are inconceivable happen all the time. And what that does is that expands our mind. And expanding our minds to conform to the evidence of reality is common sense. And that's what, when you call atheism, that's what that is. That's just saying, I'm going to accept the evidence of reality, and if something seems like it contradicts the evidence of reality or is irrational, I should question it. Now, there are a lot of ideas which gorgeous George over here, no, Mr. Tzortizs. Tzortizs. I've been to Istanbul and I'm trying to learn Turkish, but Tzortizs. Mr. Tzortizs. It's okay. Do you speak ancient Arabic, by the way?
I could read and do a bit of grammar.
A bit of grammar. You don't speak it then?
No.
So your presumption that it's beautiful ancient Arabic is just a presumption. You actually don't know what you're talking about.
No, it's
not. Okay.
Okay.
I just wanted to ask that question because I don't speak Turkish. I wanted to see if you spoke ancient Arabic. Well, I just want to ask, do you speak ancient Arabic?
Yes, I do.
Fluently?
No, but I do speak it.
Okay, but not fluently.
كيف had?
Well, you know what? There's a real language that you don't speak. It's called the language of mathematics. So let's talk about that. Let's talk about this nonsense about infinity. Let's take something physical. Let's draw a circle and draw a diameter. What's the ratio of the distance of the circle to the diameter? Do you know?
You're the teacher.
Do you know?
You're the teacher.
I know. I'm asking you a question.
No,
I want to have a chat.
I don't know anything.
Well, you've demonstrated that, but you ever heard of pi?
Yes, I have, yeah.
Oh, do you know what it is?
3.14 percent.
How many decimals does it have?
I don't remember.
An infinite number.
Yes.
Okay, so the physical distance of the ratio of a diameter of a circle to its circumference is an infinite number.
Yes.
What do you know? Now, when we talk about, what's amazing to me is you quoted Aristotle as the basis of science. Of course, Aristotle was the one that told us objects fall in proportion to their weight because he actually didn't do the experiment. He deduced it based on what he wanted. Galileo, of course, did the experiment, right? And we know, let's do the experiment here in front of you. So I'm going to take this object and this object. Yes. Aristotle would tell me which would fall first. Will you tell me which would fall first? Guess, okay. If you don't know.
The book.
Okay, look, you were right. Great. Okay, good. Why?
Because there's resistance.
Resistance to what?
To the paper, right?
Okay, exactly. Aristotle didn't know that.
Yes, he didn't.
Okay. Aristotle also claimed that infinity was impossible because indeed, as you pointed out, the distance from you to me could be divided into a half, and then a quarter, and then an eighth, and then a 16th, and that's an infinite thing. It makes it impossible.
Yes.
Well, the thing that Aristotle didn't know how to do, and you don't know how to do, is to sum an infinite series. 1 plus a half plus a quarter plus an eighth plus a 16th adds up to 2.
Yes.
Okay, so that kind of argument that infinity is impossible, it just doesn't make sense mathematically. Infinities do occur. Now, it is true in my book that I said infinite density or infinite energy is a concept that appears to be in contradiction with the evidence of physics. But that doesn't apply. All infinities are impossible. In fact, space could be infinitely large. There's no presumption that space isn't infinitely large. It could be. What we now know about physics suggests it probably isn't, but there's no law of physics that says space can't be infinitely large. So this notion that you deduce that infinity is impossible because you don't like it is just not the way the world works. Because infinities happen all the time, whether you like them or not. Not only that, it doesn't lead to irrational actions. Mathematicians have a way of dealing with infinity. We can add infinities. We can take numbers and an infinite series that, for example, the series 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 to infinity actually has, in mathematical terms, can have a finite sum. It's minus 1/12, if you wanted to know. Okay? It may not seem logical to you. It may seem inconceivable to you that the sum of a series of positive terms, each of which is bigger than 1/12, could end up being minus 1/12. But the fact that it's inconceivable to you just means you're ignorant.
Thank you.
Okay. Now, this idea that Occam's razor suggests, first of all, Occam's razor is not a principle of science. Okay, it's a nice idea that you should try for the simplest answer to any question, and physicists try and use that. Sometimes the simplest answer doesn't work. In genomics, for example, it'd be nice if every gene, in fact, you talked about more than one cause for an effect. It'd be nice if every disease was caused by a single gene. One of the reasons that genomics is so difficult is we've discovered there's a complex interaction of genes, so that in fact, that there are many separate causes of most diseases. There are very few diseases that have a single cause. But in fact, you know what is simpler than the number 1? The number 0. 0 is a much simpler reason that there's no cause. Okay, so if you really wanted to apply Occam's razor, in fact, you'd apply no causes. Now, you also use the term causality, which is a term I understand. You didn't define it. Do you want to define it?
I may do.
Well, why don't you do it now?
I don't want to give you that favor.
Oh, I thought we were going to have a chat.
Yeah, but I want to have a chat, not a chat. So it's less rhetoric, more connection.
No, let's have a chat. No, I think when we talk about rhetoric, we were talking about the lecture you just gave. I want to have a chat. I'm asking you a question. Do you know what causality means? You use the term.
Yes.
Okay.
Well,
if you use a term, you should know what it means.
Yes,
Okay,
I have my
you use it.
definition. I have my definition.
Okay. Well, I'll define it, and that's cause precedes effects. Does that sound good?
No, that's the wrong definition.
Okay. Well, I'd like to learn what it is.
Well, for example, there's an interesting book about the quantum physics and causality, and the philosophers and philosophers of science and scientists have disagreed on a specific definition. So they've reduced back to a fundamental definition. Do you want to have a chat a chat?
You quoted a book on physics.
Yeah, I haven't finished yet.
Physicists don't disagree about the definition of causality.
Have you presumed your results here? Do you really want to connect with me as a human being?
No. But
you've asked me a question, you're answering it for me? Come on.
You quoted physicists. Go on.
I said scientists.
Okay.
Now, which is the same, I agree. Now, so from my limited knowledge, and I do believe it is limited, of course, is that the agreement has been on something which produces an effect, which includes, therefore, you can have something called asymmetric spontaneous causality, where the cause exists prior causally, but not prior temporally. So there is a whole range.
What's prior causally, not prior temporally?
Prior causally means that there is I'll give you an example. The Kantian example was you have an infinite ball that's on an infinite pillow. Now, they both, time doesn't exist here, but you're not going to say the indentation is not as a result of the ball. So there is a causal dependency there, and time is out of the window. So we could discuss causality until the cows come home, but it's not as simple as what you're trying to say in terms of that. It doesn't presume temporality. Do you see?
Well, I think it does. I think again, if you think carefully about what you just did,
okay.
The ball doesn't create an indent in a pillow. And by the way, you used infinite. I thought we weren't allowed infinite. But anyway.
It was an example.
Yeah, well, it's an example of a physical example, which you said doesn't exist if it's infinite. But it doesn't matter what's infinite. A pillow here, a finite pillow and a finite ball.
Yes.
Okay? There's an indent.
Of course there is. Yeah.
Okay, was the ball there or not?
Well, my example wasn't based on finitude. It was based on they're both infinite.
Well, but if the ball isn't on the pillow, it doesn't create an indent, right?
Yeah, of course, yeah.
Okay, so it had to be. So was it put on the pillow or not?
Well, that's irrelevant. You're damning the example.
Well,
that's a logical fallacy.
No.
Get the point I'm trying to say.
The point is that the physical causes have physical effects. So either the ball is on the pillow or not. Now, the point about causality is that the interesting aspect of it is it's an interesting physical question. But what if there's no before? Let's take, you talked about the cosmology. So let's take general relativity, whose equations I'm sure you don't know. And
I said I don't know anything.
The beginning. You made it very clear that the beginning of the universe is very important. You deduced it, but in fact, deduction doesn't matter. the point is, the universe, our visible universe, did have a beginning because we can measure it. Whether we liked it or not, or whether we think it's sensible or not, it actually did have a beginning, a factor not in dispute. Our universe had a beginning. Now, however, the laws of physics tell us, right now, if we extrapolate back to the beginning, that that if we took it at face value, that time didn't exist before t equals 0. So if time doesn't exist at all, the sense of cause doesn't even make sense. And this is the key point. In science, we have to realize that our common sense notions sometimes go out the window. When we observe effects, they have causes. But at the beginning of time, when time itself may have come into existence, then that question becomes a bad question. Philosophers can debate it, people can write it down, but it doesn't matter. Now, the other thing I will say is you've somehow talked to me about the fact that the Quran as a literary document is different than other literary documents. And you've given some arguments that I understand. What I actually did this the other day because I've seen you give this talk a gazillion times. I actually input in a computer a lot of Arabic words and asked them to produce it at random. And I produced 2 sentences from the Arabic from the Quran in 11.6 seconds. My computer speaks neither Arabic nor is Arab, but produced those incredibly divine words. Now, the other question, of course, I would have is, and this is a common sense question, is why did God choose Arabic, or Aramaic, or Greek? I mean, doesn't he speak English? Or the Americans always think he does, which is why they invented the Mormon religion. So the question I want to ask is, what makes sense is to ask not the details of the Quran, which I don't want to dwell on, because it's just one of 1,000 different religions, all of which make the same claims, and all of which, if you look at them a priori, are equally ridiculous from a priori common sense notion. For example, and I got this from my late friend Christopher Hitchens, is it sensible to assume that humans evolved in their present form somewhere between 250,000 to 1 million years ago? So you have a God who creates a universe and has 4.5 billion years of life evolving, and then Homo sapiens evolve and live in incredibly awful conditions and for 250,000 years, and suddenly, in the middle of the desert, in a cave where no one can see it, he takes some poor schmo and says, I'm going to tell you the truth. And not only that, I'm going to allow you to save humanity. And, in fact, if people don't believe you,